Okay, I'm taking up the answers for this genetics quiz. I will try to explain in a full solution as if we were in class together. If you have questions, of course, you may ask. Now, I do have my mask on, so I'm hoping that you can understand what it is I am saying. First question, suppose that hair texture is controlled by incompletely dominant alleles. That's your key. The moment you see that incomplete dominance question there, you know that you have to answer things slightly differently. Okay? I told you in class, if you get a question about incomplete dominance, I don't really care so much about the format of your answer as long as there's some structure and I can follow it and you have the right answer. A homozygous curly-haired female. So C is a tempting choice. However, C, big C, and small c, they look the same. So C's are a good one to avoid. So let's use H. So we have big H for curly, potentially, and small h for straight. Because it's incomplete dominance, if you wanted to, you could say big HC for curly and big HS for straight. There's so many different ways you can represent this answer. Any of them are right. It doesn't matter as long as you understand the structure of the question. Now, if I'm mating a person that is homozygous curly with a person that is homozygous straight, this is a red herring. Let's see this right here, female and male. That doesn't matter. That's irrelevant to the question. You don't care about that. That has no bearing on the question. Some students get a little confused with that. Anyway, so here is my curly and here is my straight hair. So you're going to cross these. This one here, the only gametes they can produce are big H's, and the only gametes here they can produce are small h's. So when I run the Punnett square, I got a big H, I got a small h, I end up with 100% hetero. But it's incomplete dominance. So what you have to remember in incomplete dominance is that the offspring have a third phenotype. So this is where you tell me wavy or spirally or something. If you told me it was a mixture of curly and straight, that is a co-dominant answer, and that would be incorrect. So you have to give me a third phenotype. That's the important message here, a third phenotype. All right. Next question. Show a cross with a heterozygous type A person and a type AB person. So let me just make this a little thinner, easy to write with. So this is a co-dominant blood question, and you'll remember that I said that if you want part marks especially, you have to use the big I, small I convention. If you use the ABO convention, you will lose communication marks because that's inaccurate. You can use it as a shorthand, but it's not a proper way to show your work. So heterozygous type A looks like this. A type AB person looks like this. The gametes this person can produce are an A gamete and an I gamete. The gametes this person can produce are an A gamete and a B gamete. So I run my Punnett square here. IA, IA, IB. So here is a type, and remember when you do these questions, once you get past the single trait problem and the two trait problems, we only really care about the phenotype answers. And so some of you forgot that and you gave me an answer that was too specific. So taking a look at this, let's look at our answers. So there is a type A person right here. That's one. There's another type A person here. That's two. There's a type AB person. One of those. And a type B person. One of those. So my answer is going to be 2 out of 4, 1 out of 4, and 1 out of 4. So that when you give me an answer to this question, what you should do is you should tell me therefore there is 50% type A, 25% type AB, and 25% type B. You'll notice I'm doing it in decimals. Remember, decimals, fractions, percentages, they're all the same thing, but you need an answer. And was very important for you to tell me that there was that 50% of the offspring are going to be type A. And if you didn't tell me that, if you broke it down too much and you gave me 25% this, 25% that, then you didn't get full marks. So it's very important that you identified that this and this are type A. Next question. Is it possible for a type A and a type B person to have a type O child? Yes, it is, if both parents are heterozygous. Because these two parents here now have eyes to give. And so, yes, it is possible if you have a heterozygous type A and a heterozygous type B. 2 marks. Assuming red-green color blindness is an X-linked trait. So some of you use the full convention, and some of you use the shorthand convention. We're only dealing with X-linked recessives. I'm going to just use a little shorthand. So that's my color blindness, X. So if I'm crossing a woman who's a carrier for color blindness, she'll look like this, to a normal man. If I was using the letters, then I could say that this would be normal vision, and I'm going to use E for normal. So that would be a carrier, and this would be a normal man. I'm not going to use this convention just because it's just too much work. I'd rather use the shorthand. So once I have my parents determined, I'm going to figure out their gametes. So one defective X, one normal X, one X, one Y. Be careful with your Y. Some students, their Ys look like X's and they get confused. So this is going to be an X, defective X, X, normal X, affected XY, normal XY. So it says give the phenotype results for the offspring. So the phenotype results are 50% phenotypically normal females. And there's 25% normal males. And 25% affected males. That is your results. Some of you told me that there's 75% normal children and 25% affected children, and I did accept that. So that was 4 marks. Now this one is work. You have to logic through this question. So as I logic through this question here, I'm going to try to figure out what kind of pedigree this is. So first of all, I'm going to go to X-linked recessive because those are typically the easiest ones to determine. If it's X-linked recessive, that means I'm following the X. It means that any affected mom, every single one of her sons will be affected. And because this son here is not affected, it means that it is not X-linked. So now I'm left with dominant and recessive. So let's take a look. This is my key right here. The key to understanding this question is right here. If this were dominant, that means that they have a dominant letter. So let's say it's a big B, for example. They have one big B. That's what it means. And that big B had to come from either this parent or this parent. But neither of these parents have the trait. So therefore, it can't be dominant. The moment you see a trait like this skip a generation like it has here, then you know it can't be dominant, because dominant traits cannot skip. So therefore, it has to be recessive. And if you work it through as a recessive possibility, let's see what will work. So let's use 2 small b's, for example. 2 small b's, 2 small b's. So this marking one set would be recessive. And then you just see if it makes sense. Could they inherit a B from this parent? Yes. Could they inherit a B from this parent? Yes. Right? So as I look at the logic of this, is it possible for this child to exist? Yes, because this could be a heterozygous parent. And so on. Is it possible for this child to exist? Yes, they could have got definitely got a small b from this father, and they could have got a small b from this mother. So the recessive is a possibility. So when we check the recessive, it's a possibility. On this question, you'll notice in the question it did say explain. And some of you gave me an answer and you didn't explain. And some of you just circled. You're like, I'm just going to circle this. But circling it wasn't even an option. You had to identify which pedigree type this was. Going over here, same thing. Is it X-linked recessive? Well, with X-linked recessive, it means that if you have an affected female, it means every single one of her sons will be affected. Here's a son that's normal, so it can't be X-linked recessive. That's gone immediately. I want to say it's dominant. Like I want to go to dominant immediately because look how frequent the trait is. And notice it doesn't skip any generations. So the most likely is going to be dominant. And so I'm just going to work through it and just make sure it does work. So if it's dominant, could this one here exist? Well, they get a big B from this parent, and they get a small b from that parent. So it could exist. Could this child here exist? Well, yes, they get a small b from this parent, and they can get a small b from that parent. So based on this table, I can back work through every single individual here, and I can determine an answer. So yes, dominant can work, and of course you get a mark for the right answer, and a mark for explaining it. And finally, the last question. So a calico cat, so we know a calico cat is going to be a combination, the co-dominant combination here, is mated with a black cat. Let's just do this. Understand? Okay. So I have calico cat mated with a black male. I'll identify these. So XB, XR, and XB, that's a double X, BY. Okay. And so they have children. So they produce a black female. That's two of these. They produce a calico male, a black male. They produce a calico. It doesn't say male or female, but you can only have a calico female. And finally, the last one, we don't know. It's unknown. But it does tell you that unknown mates. It's a male. It mates, and it has 3 babies. It mates with an orange female. And it has 2 orange males. And 1 calico female. So this is an orange female, so we know that she had to give an R to her children. Right, we know that. So that means this B had to have come from this female. We know that this B had to come from dad. And we know it's a dad. He gave the Ys. So that means this is a black male. Black male. Okay. So you got 1 mark for this, and then 4 marks for your general pedigree. With most pedigrees, what you should do is you should also identify what the trait is. So if we're looking at black as our trait, then I would expect that you'd color in all the black. So this might be black, this is black, this is black, this is black. Right? So you need to, on a pedigree, you typically identify a trait, and then you color that in solid as the affected trait or the trait of interest. And that is the quiz taken up. Hopefully that helps you as you prepare for your test, which is on Tuesday, not Monday. And it's probably a good thing, so you have an opportunity to ask questions if you need.